We're going to look at density in a lot more detail here. Remember we said it's useful to consider the units involved when working with problems involving compound measure, and density is a particular example of that. So let's start with another question. How do you know that kilometers per meter cubed cannot be a measure of density? Think back to the video on density itself. Density was a mass per volume. First of all, in this measurement here, kilometers per meter cubed, there is no mass. There is just a measurement of length, which is kilometers, and a volume, which is meters cubed. So we know this isn't a measurement of density because there's no measurement of mass and there is a measurement of length. So let's ask another question. How do we know that kilograms per meter squared cannot be a measurement of density either? Well, this is a tricky one actually, because kilograms are a measure of mass, but meters squared is a measure of area and not of volume. So it's not a measurement of density of an object. However, it could be an area density, like sometimes if you look on packs of paper, the density is given in mass per area of the paper. So it's important you're able to distinguish when the units are telling you that you're dealing with a density or a different kind of measure. Let's look now at converting between compound measures at different units. We'll often need to convert from one measure to another. So we're going to look at exploring the idea of density and how we can convert between different units of density. First, you have to remember, of course, the basic equation connected to density. Density is mass divided by volume. So let's look at a problem involving density and converting between one set of units and another. So what is 120 grams per cubic centimetre if you convert that into kilograms per meters cubed? Now, there's a problem when converting units when they're involving compound measures, because we've not just got one set of units to convert, we've got, in this case, two sets of units. We've got to convert from grams into kilograms and from centimetres cubed into meters cubed. So it's important that we do it in several steps to make sure that we don't make any mistakes along the way. So the first thing we're going to do is convert the 120 grams into kilograms. We do that by dividing the 120 by 1000, and that gives us 0.12 kilograms, because we know that 1 gram equals 0.001 kilograms. We now also look at the conversion from centimetres cubed into meters cubed. This is trickier. A 1 metre cube has 100 centimetres on one side, 100 centimetres on the other, and 100 centimetres on the other. So a metre cubed is the same as 100 centimetres times 100 centimetres times 100 centimetres, or 100 cubed. So 1 centimetre cubed equals 0.00001 meters cubed. So 120 grams per centimetre cubed can be converted into, well, the 120 grams we know is 0.12 kilograms, and then we also then have to divide by the 0.00001 to get it into meters cubed, and that gives us a solution of 120,000 kilograms per meters cubed, and that's about 10 times the density of gold, so that's quite a dense substance. So it's not that difficult to convert between different units in compound measures, as long as you do it in at least those two steps. Make sure that you check your answer at the end by thinking, is that about right? So if you think about it, 120 grams per cubic centimetre, that's quite heavy for a small thing. If you think about a dice, which is about a cubic centimetre, and 120 grams, well, that's, you know, about a quarter of a pound. So that means that the density that you have there for a meter cubed, which is quite a large thing, it does make some sort of sense. Most often mistakes are made by dividing instead of multiplying, and ending up with a number that's very much too small or very much too large. So always do that sense check at the end to make sure that you think you've done it the right way around.